Swayam Prabha. Digital India. Educated India.
The fourth one is to really understand what are the words and what those words convey, right. So, that is something that we need to understand in order for us to go to the next level, right. So, there we want to find out how can I really do certain mathematical operations on the text. Can I really convert the text into some vector form, and can I use some vector algebra to do certain vector algebraic methods to find certain inner meanings or find documents related to what I am looking for and so on. To give you one idea, let us suppose we have a document collection containing about billion words and about 10,000 documents, and I have a search mechanism to find what is there in the document. Let us assume that there is a search engine that is running behind, and then I just give the word by, right. So, what it should do is normal search engine should go and then look for the word by and then get me all the documents where this word has occurred, right. And then it will list based on some ranking. Let us not worry about the ranking right now. Let's see that it has listed certain documents in certain order, and then every document will have that word, right. So, we do not want just get to that level. We also want to find out document that contains words and so on. So, we started with by, right, and then the rudimentary search engine gave me certain results where all the words, all the document that contain the word by are listed in certain order, but it will not list anything which are related to bot or if the documents contain these two words, right. So, what is the next step? So, is it possible for me to get these things done in certain way? So, there is one simple way that we can do is we can use either stemming or lemmatization. Let us talk about that. We will talk about the details of that little later. So, where when you give the word bot, it will be converted to by. So, you look at all the verbs in this fashion and convert them into the root. Then you are normalizing the entire corpus. Wherever you have seen this word, bot will be replaced by this word by, and buying would be this. So, in that case it is possible for us to get all the results that contain the word by. So, that is one way of doing it, but that is not very good, is not it. So, there could be a lot of document that will be incoming, you cannot expect everybody to keep doing this pre-processing step, and that is also not really nice, it is not the way to learn the language and so on, especially when you are trying to make the machine learn this. So, what are the ways? So, is it possible for me to use some vector space model to find out the distance between buy and bot and buying? So, if they are close enough, bring all the words that are close enough to buy and then get those documents where those words are close enough to, right. So, once you find this using some mechanism, it is going to be possible for you to list all the documents which do not list all the documents that do not. Once we do that, it is possible to list all the documents that not only contain this word by, but it will also list all the documents that contain the words by and buying, correct. So, this is something which we want to achieve. Is it possible to really get those in certain fashion? So, can vector space model for words would really help us? This is what we are going to be looking at in the vector space model. So, in the way we want to do is each word would be represented in one axis. For example, if you have about 7079 words as your vocabulary, and if you are representing the words in the vector form, there will be 7079 axes, because each one would be independent of each other, each word is independent. So, that is one way of starting the process to convert your words into vector space model. And then later we need to start aligning those vectors in a way that if the vectors are close enough for a given word, make them as one axis. So, we will see how that could be done little later. And then if you have about 3 million words in the corpus, we are going to have 3 million axes. That is pretty huge, right. So, it is very difficult to imagine beyond 3 axes for us. So, we need to be able to do certain operation in the vector space model to reduce the number of axes, at the same time bring in those words that are close enough into one axis. So, that is the main idea of the vector space model. So, as I mentioned, right, we need to be able to plot them in the axis and try to minimize the number of axes, so that we have less number of variables to deal with. So, we will talk about this in one of the lectures in the following weeks. Okay. So, once we are able to represent these words in certain way, can we create semantically connected vectors? Okay. So, where we want to be able to find the relationship between terms and documents, right. Like I mentioned earlier, buy, buying, bought should be brought as part of one axis, not 3 different axes. So, in that way we are connecting those words together, and there could be some synonyms related to buy that also should be brought as part of that particular axis, okay, to which all of these synonyms and word should belong. So, as I mentioned earlier, we need to be able to put similar items closer to each other in some space or structure. A model that discovers or uncovers the semantic similarity between words and documents in the latent semantic domain. So, is it possible for me to translate from the terms and documents from one domain to a different domain, so that I will be able to uncover the relationship? So, we will look at that as one of the important aspects as we move along. Okay. Develop distributed word vectors or dense vectors that captures the linear combination of word vectors in the transform domain. For example, when you are transferring from one domain to the other, what happens in the transform domain? So, the words are transformed into a different set of vectors. Does it really convey the real meaning of the word that we see in the world right now, which is in front of us? For example, the document that you are seeing contains the words and paragraphs. So, in the transform domain, how do they look like, right? So, we will be looking at converting the words into word vectors or dense vectors. So, this is very important step to do. If we do these kinds of operation, we will be able to get into the transform domain and then see certain latent relationship between the terms and the documents. Okay. So, thereby we are learning what the word is all about. Okay. The word will not just represent that word alone. So, it will be looking at all the contextual word that is surrounding that particular word, or the synonyms that the word has. So, those are converted into a certain form which we will be using for certain NLP applications. Okay, so, those we call as word vectors or dense vectors. So, we will go through this in detail. Right now it might look very overwhelming, right. When we go into the details of that, you will understand the importance of each of this, and I think you will understand the reason why we are converting them into a different domain and so on. So, I am going to skip this part right now. Maybe the last section of this slide I will talk about. So, for example, if you have two documents, assuming that only these 4 words, okay, the first document contains automobile association and the second one is car driver. Okay, so, these are the 2 documents that we are looking at. So, is it possible for me to connect these 2 documents in certain fashion? Can we connect automobile and car automatically, or can we connect the driver and the automobile association to which he belongs to as one? So, these are a certain kind of operation that we want to perform on the corpus. So, starting again from the beginning, right. So, we started looking at the counting part, and then we started looking at, based on the counting, can I do some prediction. So, now we got a little deeper into understanding the word, right, in terms of the context in which it is present by creating a dense vector. Dense vector does not just represent that word, but it may represent the contextual words that is surrounding it, or it may also represent the synonyms associated with that. Okay. So, once we have that information about the word, so can we make the system learn these associations? Okay. Do we have enough information to really convert the data into certain form that machine can use and learn and understand? So, we do not have a lot of information, even though we can talk about a huge corpus containing billion words or 1 trillion words and so on. The reason being, every time we create a sentence, we always form a new and innovative one, right. So, it need not be part of the a corpus that contains about 1 trillion words or 1 billion words and so on. So, we are very innovative in that fashion. So, we always lack sufficient knowledge, okay, in order to feed into the system. It is very difficult to get everything that is possible as a knowledge and then feed it as part of the knowledge base into the system, right. So, how do we solve problems when we really lack sufficient knowledge, right. So, we start reading more, we start listening to new lectures and so on, right. And then we start looking at examples, and we start looking at the experience that we have gained. So, these are certain things that are helpful in terms of learning. Okay. And then examples really provide certain underlying patterns. So, based on what is already available in the corpus, right. So, those are the examples that are already there. So, we can look at some underlying patterns in those, okay, and then try to fill in the missing information using those patterns. So, these patterns gives us the ability to predict some outcome a pattern always would give you this ability, right. So, we can always build certain models and then claim that this model would be able to solve certain problems, but the model will not be able to solve every problem. So, how do we keep creating new models based on what we have learned? Okay, so, that is where learning comes into the picture, especially in the machine. So, we keep providing more and more information to the system, and then it starts learning the patterns and probably creates a newer model every time. One example that I can provide here is, I am sure most of you would have used the translation from the big companies that are around, right. If you had used the translation 3 years back, and then if you had used the same translation from the big companies today, you would see a huge difference in terms of the quality of the translation. The systems are learning as they move along. So, the learning is one of the most important thing to have in order to really work in the ambiguous world. So, keep learning from the examples. So, every day is an experience, every day there is a new learning that comes into picture. So, we keep changing the models, a model cannot stay static forever. So, the model keep changing on a regular basis, especially the machine learned models are something that you have to keep changing on a regular basis unless the data does not change. And we look at various linear and nonlinear classifications. For example, we spoke about the clustering earlier, right. So, based on the learning we start refining our classifications in a better way. Okay. So, those are the aspects that we keep learning as we move along. And then we talk about certain low level neural net models like perceptrons, its learning and so on, and then move into the higher levels of feed forward neural network and back propagation algorithm. So, why do we do all this? So, we spoke about the vector models earlier, right. So, the neural networks that we are going to be looking at for machine learning would require the data in the numerical form in some way. The neural net models usually learn the patterns very well. So, some of the patterns that is very difficult for us to learn, the system would automatically start predicting based on certain training algorithm that we provide to it. So, it is very important for us to do this step in terms of creating the vector space model for the words. So, we can start feeding those vectors as input to the neural network, and then during the training process they start learning, and then the outcome would be really good, if it learned the data and the patterns very well. Okay. So, we spoke about the vector space models. Again, when you do the neural network based application, word embedding comes into the picture. So, whatever we spoke about as dense vector, again we do the same thing with the machine learning. Okay. So, we start creating the dense vectors using neural network as well, using certain pattern that we provide as input. So, using which we would be able to find semantic similarities, syntactic similarities, or both. So, how do we do that is something that we talk about. So, you remember we spoke about why. So, why is about why do we do this natural language processing, okay. And then I gave certain examples of what we do there, right. And then what are things that are required for us to do this in order to get to the answer of why, and then how do we do that. So, these are all the what parts in terms of what we need, especially the dense vectors, the probability that we spoke about, they are all from the what part. Okay. And then how is all about how do we really implement that. So, what are all things that we have to do in order to implement that, and that would answer the question on why do we do this. Okay. So, look at this as the most important thing, every time when you do certain things, try to answer these three things. Okay. So, in the entire course we are trying to answer all these three questions. Okay. So, we spoke about this, right, in terms of the word vectors. So, we can use a mechanism in the linear algebraic space using a method called SVD, singular value decomposition. Okay. So, that also gives you a dense vector, and using neural net also you can do the same thing. So, neural net provide a better word embedding than SVD in many cases. Okay. Okay. So, how do we do that? So, we have various models using which we can convert the words into dense vectors. So, using the dense vectors, it is possible for us, as I mentioned, to understand the semantic similarities, syntactic similarities, or both. For example, also remember this code. So, this is a quote from Firth. So, what he said was, a word is known by the company it keeps. That means the word always has certain contextual words surrounding that, and if the context word are the same, but the central word is a little different, then we can say that those two words are somewhat similar in the semantic way. So, that is exactly what he means, and the neural net model exactly captures these patterns in certain fashion, and then the word embedding are created, or the dense vectors are created, which we can use it for later applications. So, now we spoke about at a very high level, again I am repeating, the counting of the words in the corpus, and then we did some prediction based on what we counted, and then we started learning more about the words in terms of the semantic connectivity or the contextual information using the vector space models as well as the machine learned model. So, once the words are understood in certain fashion, so the next is about understanding a sentence, right. So, it is all about that, right. So, starting from the number, now some meaning about the words, can I look at the sentence as a whole to understand that. That is where the sequence learning comes into the picture in the natural language processing. So, we start doing the sequence learning when we have the understanding of the words in certain fashion, right. So, you can define the sequence learning as the study of machine learning algorithm designed for application that requires sequential data or temporal data. Okay. So, that means I am going to be expanding my horizon in terms of learning what the sentence is all about. So, starting from the numbers, the words, now the sentence, right. So, see the progression that we are making. So, that is where we are going to be bringing in the new models. So, the old models are good for word understanding and so on, but they are not good enough if you want to really represent words as or the sentence as input. And then how do we do this is where a recurrent neural network comes into the picture. So, this is one of the key problems. Sequential data prediction is considered as the key problem in the machine learning and artificial intelligence. So, if you are able to understand a sentence, that means you are gaining more and more knowledge about that language and the words that are there in the sentence, right. And language understanding is always about the intelligence. So, we are trying to bring in more and more intelligence into the system by starting to look at the count, starting to look at the prediction part, and then trying to find out how words could be constructed, and then now try to use those knowledge that we have gained and then see if we can really understand this sentence, which is nothing but the string of words, right. So, in the case of the natural language processing, which is nothing but this string of text, a combination of sentences, combination of paragraphs and so on, we read this sequentially to understand the content. It is very important, is not it? So, we can't just throw away certain words, and then if the words are not in order, it is very difficult to understand that. Unlike the image where we only look at portions and then we are still able to make it out, whereas in the case of text, if you are only thrown one word and then if you are asked to construct the entire paragraph, it is going to be very difficult, right. So, if you are given some portions of the image, you may be able to extrapolate that. So, even in the text it is possible, but I am not sure how close we can get to if you are only given certain words to reconstruct the paragraph. Okay. So, it is a task that requires a sequential understanding of the content. So, what we are going to be studying in this recurrent neural network, we will talk about the architecture of the recurrent neural network, we will talk about the language model. Is it possible for me to really predict the next word or say that whether a sentence is legally right or wrong, I mean in terms of the syntax. Okay. And then how do I encode a sentence into a fixed sized vector? Given a long sentence of 50 words, can I compress that into a fixed sized vector like we had done in the embedding of words? Can I create a embedded or a dense vector for a sentence? And then we talk about what happens when we try to learn long sentences, because there are some inherent problems in the neural network that we would like to address and bring in new models using LSTM and GRU. It is long short term memory and then gated recurrent unit model to make sure that we do not get into the trouble of exploding and vanishing array. These are all the model constructions and that we will also take a look at those. Okay. So, I will be covering in detail all of these in the subsequent weeks.